This alternative deviation has to be a full strategy. Okay, it has to tell the player what to do at every point. So let me just, I'm not going to write it out, but let me be clear about what I mean here. So this alternative deviation is just like unconditional defect, except it doesn't start in the first round. So what I mean here is defect in every round after cooperating in the first one. Okay, and we're studying that strategy as one representative of any strategy that involves cooperating for a while and then switching to defect. We've already, under point 2 there, argued that any strategy that involves cooperating after defecting, there's no gain from that. Okay. So for this alternative, we'll look at the first round, the second round, the third, and again, we'll hope that by then the pattern emerges, or we'll go out a few more rounds if we need to. Okay, so this alternative strategy, this deviation from Grimm-Trigger says cooperate once. Okay, that's what it's telling us here. So I'm going to cooperate here. Column, remember old Column, the guy we're playing with, he's still playing Grimm-Trigger. Okay, so Grimm-Trigger says nobody's defected, you cooperate, we both cooperate, and I get my payoff of 3. I'm the real player. Okay. Round 2 comes along, and Column is still playing Grimm-Trigger. So as far as Column's concerned, nobody's defected to the past. He cooperates. But I'm doing this alternative strategy, this kind of stealth strategy. Yeah, last time I let him think that I was a cooperator, but I'm really not now. Now I'm going to defect. Okay. So now in this round, I defect, he cooperates. I defect, he cooperates, I get my 5 right here. Okay, and next round I'm going to continue defecting. Column is playing Grimm-Trigger. Okay, so that defection in round 2, that was enough for him. He's done with me, he'll never cooperate again. Okay, so we get a payoff of 0, and it's 0 forever here. Okay, all right, so let's remind ourselves of what we need to compare this to. The present value of Grimm-Trigger, we've still got the whole analysis up over here, and that's actually nice because that can help us remember what we're going to do for the alternative deviation here. So this part of the equilibrium analysis, we compared the present value of Grimm-Trigger to the present value of unconditional defect. What we want to do now is compare the present value of Grimm-Trigger to the present value of this alternative. Okay. So the present value of Grimm-Trigger, I wrote it out in the form that came from the table. It's this stream of a payoff of 3 in each round successively discounted more and more. That's a geometric sum that reduces to 3 over 1 minus delta. So I'm just going to use that again here. Payoff of Grimm-Trigger is still the 3 over 1 minus delta. Okay, all right. And the payoff to the alternative deviation over here is 3 plus 5 delta. Okay. All right. So there would be more. There's several ways to solve this. One thing you can do is just ask yourself what conditions on delta make this at least as high as the present value of the alternative deviation. That's one thing we can do. Another thing we can do, though, it's actually, in this case, I think helps us a little bit more if we look at the very first version of how we wrote the payoff for Grimm-Trigger. So we're sort of undoing the work that we did here. This was applying the formula, but what we started with was 3 plus 3 delta plus 3 delta squared, et cetera. Okay. You're thinking, she's going backwards. Why is she going backwards? Let me show you why I'm going backwards. Okay. The present value of Grimm-Trigger is greater than or equal to the present value of the alternative if 3 plus 3 delta plus 3 delta squared, on and on and on, is greater than or equal to 3 plus 5 delta. I'm going to simplify this a different way now. Okay? It would be totally fine to just do the algebra to do this comparison, and I really encourage you to do it, but I want to show you a less obvious way that also works and that to some extent I think highlights the logic a little bit better. Okay? So what I want to do is I'm going to notice here, first of all, that I have this 3 by itself, not multiplied by delta, on both sides here, because in this very first round, with the alternative deviation, the players are making the same choices that they would if they're playing Grim Trigger, so that doesn't affect things. Okay, so now I've got 3 plus delta plus 3 delta squared plus 3 delta cubed, all those things, blah, 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 greater than or equal to 5 delta. Now I have an inequality that every term has at least 1 delta in it. Okay, so I can factor that out. Okay, so I'm going to factor out delta here, and I'll get 3 plus, now there's just 1 delta here. My delta cubed term that would be next here now will just be 3 delta squared. Okay, and on and on and on. I'm just factoring a delta out of everything. And now I can cancel out the delta, divide through by both of it. This is why I wanted to do it this way. Does this look familiar? This is exactly the same condition for Grim Trigger. Okay? And again, that's why I wanted to undo the work of the, that the geometric sum formula had done here. Okay? This is the same condition as for unconditional defect. So what this is telling us is that if you ever are going to just defect, if you're ever going to be the first to defect in the Grim Trigger, doing it right away will, if it's optimal to do it any time, if it's optimal to do it after 1, it's optimal to do it right away. Okay? Saying that in a more positive way, if you don't want to defect to unconditional defect, if you don't want to defect in the very first round, you're not going to want to do it later. Okay? And that kind of makes sense, right? This says defect for the first time, the second time you meet. If it wasn't worth your while to defect the first time, why would it be worth your while the second time? Because the game looks the same here. You still don't know when your last round is going to be, and the payoffs that you would get would be the same. Okay. So this part of equilibrium analysis in repeated games is quite a bit harder than anything else we've done in Poli-Sci 30. And I would say that I've taken you through the logic of comparing all the possible deviations for Grim Trigger. You could probably read on your own about other equilibria in the repeated prisoner's dilemma, and I'll have a little bit to say about that in the next unit. The art of game theory, much of it comes in figuring out in a repeated game how to organize this huge number of ways of deviating from the conjectured equilibrium into a small number of categories that you can wrap your brain around. And the way to do that is to try to figure out which way of deviating is the most tempting, okay? Or which small number of ways of deviating from the equilibrium strategy. Okay? So that can be tricky. Doable, but tricky. And one other thing I wanted to say about that. One thing you don't want to do, so here I'm saying, yes, equilibrium analysis for repeated games can get complicated. But one place where it should not get too complicated is resist the temptation to start comparing one deviation to another. Okay, it starts sounding kind of interesting. Well, is this, if one player was playing this, would I want to play that as a best response? Don't start doing that. Okay, always pin down the I don't have it written down anymore. Always pin down the strategy that you are thinking of as the equilibrium, okay? Everything else is a deviation from that. No deviations from deviations. If you think that unconditional defect is an interesting equilibrium to study, make it the candidate for the equilibrium and think about all the other things that you could do as a response to that. Another point that I just wanted to underscore here is usually in the prisoner's dilemma, we're interested in symmetric equilibria, where both players are playing the same strategy. Okay, those are logically easier to think about. It's not necessarily required, right? But there could be equilibria in which players play different strategies. Okay. So let's think about what we did in this overall process to answer the question of whether the shadow of the future could sustain cooperation, by looking specifically whether we could get mutual cooperation in the repeated prisoner's dilemma, and we got even more specific by saying, could Grim Trigger, as a contingent strategy, support cooperation in equilibrium in this repeated game? Okay. In doing that, we compared the present value of the stream of payoffs from Grim Trigger with the stream of payoffs from unconditional defect. So that was a process that required the use of the geometric sum, and it gave us the important part of our answer. The answer to those questions in this game, this prisoner's dilemma, cooperation can be sustained as long as the player's discount factor is at least 2/5. Okay? The number 2/5 depends on the specific payoffs in the game. So in your homework assignments, and indeed in the next lesson, we're going to see how changing the specific payoffs here will change the threshold for delta. So that's a process that I want you to be comfortable with doing on your own with a different set of numbers. The final part of the argument that Grim Trigger was indeed a Nash equilibrium when the discount factors were high enough involved thinking about all the possible ways to deviate from Grim Trigger. Okay, figuring out that unconditional defecting for this particular game and Grim Trigger as a particular strategy, unconditional defect was the most tempting deviation. This is going to be true whenever we're looking at Grim Trigger. Okay, so you're not going to have to do this kind of analysis for a different strategy in a different game. That's something that I would regard as beyond the scope of Poli-Sci 30, though I hope you get a chance to do it in some other class. Okay, so what you want to take away from Unit 13, from the 3 lessons that we've done so far and the final one to come, is the ability to find, given the short-term stakes, the stakes of the stage game, to find the conditions under which Grim Trigger will support cooperations. And those conditions are always going to involve some minimal discount factor. So in the next lesson, the final lesson in Unit 13, we'll look at a case that's not quite as symmetric as this, a case where the players have different payoffs.